ladies and gentlemen, a very good morning. So today we are going to present our paper on vector distance-based spelling checking system in Nepali language-dependent heuristics. So technology has empowered us to author the documents, to write the blog, and share our opinions in a very easy and convenient way. Yet we have not been able to compose sentences, or the technology has not enabled us to compose the sentences and to write words in correct spelling. So spelling checking is crucial in the application like word processing, email clients, data entry, and many other natural language processing applications. Basically, the error that may introduce in our text is due to tools generated. Sometimes we use transliteration tools, and sometimes we use keyboards, and sometimes we use OCR system. And the error may introduce by user also. So the non-word error that introduced in our text is typographic, or it may be cognitive error. And spelling checking can be done automatically in real word, that is context dependent, and sometimes it is a non-word error. So the problems in Nepali language are actually word compounding. I'll just tell you those words that is not rendered properly there in that computer. So that is due to problem in fonts. Okay. So that is pokhara, pokharama, pokhara tiraka. Okay. So that is the word compounding. That means we add postpositions and case marker along with the head words. So that is one problem in spelling checking in Nepali. If we attach postposition along with the head words, it is treated as a single word in Nepali. So that is a problem. And the second thing is font encoding system. We use TTF, that is single byte font encoding system, and Unicode, that is multi-byte encoding system. So that is another source of problem for spelling checking. And the character conjunct. Okay, we combine the characters. So while combining the characters, actually, this is Sirabindu and Chandrabindu. Okay, so the position of Okar and Sirabindu or Okar or Chandrabindu, that makes actually the problem in spelling. So here in use of vowel, we can use Raswa and Dirgha along with some characters. So people are much confused about Raswa and Dirghas. That is another problem. And orthography changes. Sometimes while making the character conjuncts, while attaching some character to another character, it forms different orthography. So that is another problem. So some work has been done before in Nepali spelling checking. Bala and his team has developed some ethics rule to generate certain language for morphology-based spelling checking. Actually, it has greatly suffered from lack of word because they had to use the generated word in their morphology-based spelling checking, and it does not support the single byte encoding system, that is TTF encoding system. Microsoft Office, in its earlier version, they have used some language pack as a spell checker, but this is only useful for Unicode and not for the TTF fonts. And some other spelling checking, actually, he suggests a vector distance on n-gram statistics as a better solution, and longest common substring is also used for ranking. Leristinian and Demeru, they suggest minimum edit distance to measure and select a candidate to replace while providing the selection for misspelled word. And Chaudhary, he maps phonetically similar words to a single phonetic word. So Sasu proposes edit distance and the Bayesian distance theory for spelling correction. Let me introduce the problem. Let me introduce our system for spelling checking. This is for non-word spelling error. And we have used two different measures for ranking the spelling solution. The first one is language-specific heuristic, and the vector distance between n-gram to list out the promising replacement. So the candidate ranking is basically done on the Lewistinian distance-based measure. So it both supports for TTF fonts, that is single byte, and the Unicode multi-byte encoding system. Yeah, let me give you one example here. This Birodh here, there are many chances of error. Sometimes people are confused with this wa and va. Sometimes they are confused with this vowel, and sometimes this the, you, and the. Okay, this they are these confusing characters, and sometimes, like while writing raw along with some characters, it forms different orthography. So that is another problem. Okay? So this is our architecture of our system. First, we put the Nepali language text, and it recognizes the text on the basis of white space, and we have used our font unifier that actually converts all the TTF fonts to the Unicode. And the suggestion for actually non-word error can be detected by using dictionary. So if the error is if the word is misspelled, then it has to provide the suggestion. So the suggestion is based on this Nepali language dependent heuristics and anagram based vector distance. So the suggestion will be ranked, and the top ranked suggestion will be provided to the system. Now I'd like to ask.
So, my name is Basnet. We tokenize word based on white spaces. This is basically a wrong direction, because word in many languages they have multi-word expressions. Tribhuvan University is a single word; it's not a white space separated word. But this is our assumptions. We use white space tokenizer. The next component we use font unifier. We design a finite state machine to convert all TTF glyphs. All TTF glyphs to the Unicode conjuncts represents in Devanagari text. So we use font mapping tables. This is the manual effort we have given. So font mapping table and glyph rearrangement rules, because Unicode renderings uses different rearrangement rules than the TTF font rendering. And then we use runtime cache so that a user get better experiences while converting from TTF to Unicode. And Unicode to TTF to preserve the integrity of written Nepali text. We construct our dictionary using different rules. Basically, we use our dictionary from Nepal Academy. This is Birodh Nepali Sabdakos. And then we use some heuristics to generate many words, and we combine those words using some manual effort. And also we use some heuristics to filter the postpositions attachment in the compounding words. We generate spelling suggestions in two steps. Basically, first we use language-based heuristics. Means people tend to make mistakes on Chandrabindu, Seribindu, Baimatra, Vaina, Talpure, Bardani. We use those heuristics to generate candidate words in the first step, and then second step we use anagram-based vector distance measurement. This is the statistical measurement, and these are the formulas and heuristics we use, because these lines we use not to make over generations and not to make under generations. This is the heuristics we designed for Nepali language, because if we generate many anagrams, it will easily go for non-word suggestions in many cases, and sometimes we miss the relevant suggestions, so that we use these heuristics to filter those out. And basically we use TF-I, vector similarity to identify whether the given word has some similar word suggested.
We have to interrupt. You have to move to conclusion.
Okay. Okay. This is the
Very few seconds
simple
remaining.
geometrical interpretations. We use about 500k words selected from Nepali news corpus. We collected for many years, and then our improved heuristics gives us 92% of accuracy. We still have something to work upon it because some word like kinabani, they have to come together. So, and also full haru and full haru both have correct word but used in different contexts because it has different meaning. So that our next work, and we are working on context-dependent spelling solution system, so that we could give better suggestions. If people write full haru in terms of rasso full haru in terms of
Thank you very much. We have to interrupt.
Okay, thank you.
Okay. Questions from audience.
Hello. Sorry, I missed a couple of minutes of your earlier presentations. So is this going to be app or server-based application? How is it going to work? Browser-based?
I think Birodh has really answer for it.
Okay.
Basically, we have developed the engine, so you can have some API so that you can use it anywhere. Currently, we have used some web-based API so that we have our own editor, so people can simply put their text in that editor and it simply.
So is it now in production form?
Yeah, it's already used by some of the media houses,
Okay.
Largest media houses in Nepal, and some government agencies, some ministries, even Prime Minister Office currently use this system for their study.
Okay, so how would you, I mean, one thing I confused between full haru and full haru, right? Both of them are right.
Yeah.
So how do you say spelling check over there? Spelling is right both
That is
ways,
our
right?
next work. Okay, currently we are working on it.
Okay, you are working.
Basic idea, we use some anagram modeling of words because full haru means the rasso full haru comes from like challa, like roti or roti,
Okay.
something like that, and then we use some context analysis using anagram spectrum.
So mostly I personally use when I type Nepali, I just use the whatever Google provides, right?
Yeah.
That's RUDR and Rudra, right? I use that. I mean that's the easiest one and very convenient. And we all type very fast. And is that application? Your things will be applied over there?
Yeah. First, you can type using that Google tool, and you can use that text in our application so that it suggests you the better, the correct word spelling.
Okay. All right. Thank you.
Thank you, presenters. Next, we have the paper, Visualizations of Learners' Behavior in Online Learning System.